Today's topic will be how to apply some wetness or snow or sand for this entire scene at once. So I've already used here one thing that will be useful for us, namely this feature. It changes the color, right, of everything. So the color of this emissive on the door, of the emissive light bulbs above, the cables, and the window, not only emissive but also tint color. So by press of one button I change them all. And as I will show you, it's really simple. It's not like calling every object and changing its properties. Let me open that. Button 2. Okay, this is this button 2. So this is animation, animation, animation. The only thing that we're interested in is that when it's the current button and it finished, it started animating, it also updates the global color. So how does it do it? It says set vector parameter value. There is a collection, material parameter collection, parameter name, glow color, and the color, because this is animating. So maybe I can show you again. So let's say I'm having this active. Now when I press this button, you can see it gradually changing. It's not an instant switch. Maybe I can do time dilation, right? How to actually do it? Slow motion. Slow-mo. Okay, slow-mo half. Look now. Or slow-mo 0.2. So you can see it's fluently changing. So that's why the code is more complex, because it gets the current value of that global color, interpolates that toward the goal color, and sets the current state back to this glow color. So what are these collections? Let me browse to it. Collections are assets. You just create them by right click, materials, material parameter collection, like this. Material parameter collection. And once you create it, you have scalar params and vector params. So just press plus. There is a new param. You expand that, give it a name, my color, set it the default to whatever you want. And then later, it's very easy to set it up in Blueprint, because you just do set vector param without anything, not predictive data, not mesh, just the base one. Select the collection, select parameter, change the color or the value. That's it. And then in materials, it's equally easy to use. So let me open this emissive material. Fortress Glow. There is glow color that comes from collection. How to do it? Right click, collection parameter. Select the collection, select the parameter. My color is already there. That's it. That's everything. Of course, we'll update these collections in the running game, right? So I additionally added one more global thing. Ah, it's not here. Okay, never mind. I thought it's this one. But sometimes I add one more parameter called isGameActive. Default 0. So by default it uses some other color. And then I set it to 1 in the running game. Here I haven't used it, but just saying that you may want such mechanism to not only have this, but also do something like scalar parameters. Is game running 0 by default. You set it to 1 when begin play on the begin play in Blueprint. and then you do collection parameter is game running, and do if or verb, but if is okay here, it won't lead to a branch. For such simple values, if they are static, if they are global, then if is okay. So if this thing is bigger than 0, use the glow color from collection. If not, use some default yellow thing. You know, to avoid black materials when nothing is chosen. So this is how global parameter collections work. Legomir says that this is like a map. So you have a map of names and values for them. So there can be only one parameter of the same name leading to one value. Let's delete this. No. Okay. Wait a second, because I thought someone was writing somewhere. I got some notification, but don't know where. Oh, nothing. Precolist asks, sorry for interrupting, but I decided to start learning Houdini, and my only question is, where should I start? So, as always, I would always recommend go to Simon's ArtStation and pick whatever interests you. For example, Houdini tutorials, quick starts collection. And yeah, side effects also has a lot of good material. Right now they launched this Project Titan, this tech demo. They're showcasing their tools. So here you have a lot of tutorials. But you can also just go to learn, go to learning paths, and pick whatever interests you. So here. And if you want a very easy tutorial about Houdini's vertex color, there's also one on my website here. So this is how I randomized vertex color, but not per vertex, but actually per item in a mesh. I think it's very easy to follow, when I export FBX at the end. So yeah, that's for links. Okay, so back to this. I know it's a desert, so maybe I should delete this fog. Oh. But does it matter actually? Okay, maybe it does. Where is this hide fog? Hide fog. Hide fog. Ah, here. Okay, let's make it gray. Let's make it higher. Good. Let's make this ground a different color. Where's the color of the ground? Oh, here. Fortress ground. Let's make it greenish. I don't quite like it, but whatever. Okay, good enough. So maybe let's change the color of the walls to match. Or something better. I don't know if it's better. Not quite. Maybe like this. Okay, that's cool. Right. So what I want now is I would like to apply, let's say, wetness to all of that. And this is tricky. This is tricky because Android's post-process don't allow to write to GBuffer. So by GBuffer, I mean that in buffer visualization, we have base color, right? We have roughness. We have, of course, normal. So what I would like to do in a post-process is to modify that roughness, like globally, change it. I already have these values, right? So why can't I do a post-process that just goes through this image and based on normal, finds the top facing surface and just colorizes this roughness. But unfortunately, this is impossible in Unreal without going into code. Supak, I think your link got cut out by the anti-spam on Twitch, so you can share it on Discord. Yeah, so we can't modify the GBuffer despite, you know, having it in one place. So what we may do instead is to make a material function that we put into every material we use, and they will refer to exactly the same global collection. Okay? So let's make content new folder. Let's call it global weather. Let's make materials, material parameter collection, MPC, global weather. And in this, I will add something like rain intensity, 0 by default. Okay. Oh, thanks Adel for sharing this link. I added global weather with one parameter, rain intensity. Now, let's make a material function, mf, global weather, apply what? Apply surface or apply rain? Maybe apply rain or apply effects. Apply effects. Let's double click it. Make it expose to library. Categories tag art aid. Okay. And now, what will this thing will do is that it will take material attributes. So wait, let me make it bigger. Because the goal is to make all of this shiny and darker, okay? So I'm going to make an input, function input, of type material attribute. By default, yeah, use previous as default. Make material attributes. Or maybe no. No. Okay, let's do it. Input will be called material. Output will be called result. And in this material, I'm going to break material attributes. Okay. Base color. Or no, even better. Get material attributes and set material attributes. So it will already take what was in the input, and specific ones will be red, like base color, metallic specular roughness, anisotropy, no, emissive, no, not exactly. Need to modify, don't need to modify metallic actually, just modify base color, roughness, normal, probably, and that's it, nothing more. And this base color will be multiplied by some constant, like gray, just to darken that. Roughness will be lerped. And we need one more thing. Material, no, collection parameter. Collection will be global weather. Parameter rain intensity. And it will be used as alpha to blend between this and between standard roughness and roughness of 0, or rather 0.001. Here to multiply, I also need to lerp between white, so neutral, and this darker tint, also based on rain intensity, like this. And I also want to modify the normal, probably by flattening that normal. So flatten normal by the rain intensity here. Maybe not that much. By rain intensity times 0.3. Okay. And now I can make material attributes, or set rather. So again, setting base color, setting roughness, setting normal, like this. And to result. However, one thing is missing, because we are applying all of this, but we're applying it regardless of the direction. But for now, it doesn't matter. So what does this function do is take material attributes and modifies them, darkens the base color, makes the roughness more shiny. So we can actually type that. So it's readable. Comment. Darken the base color. Make rough. Make surface more shiny. And simulate the simulate what? Simulate the accumulated water. Water. Flattening the normal. Like that. Cool. So it applies these effects. Now, let's go to one of the materials, this one. Open it. Open the material, generic simple actually. We will need a duplicate of that. So this generic simple. Let's duplicate that. Weather. Move here. Oh, now the viewer counter refreshed. 9 people. Awesome. Okay, it's saving the asset. Cool. So we have our M global weather, generic simple. Okay, so this is a simple material, but we will use make material attributes. We will make the material use material attributes here on the left. And now, base color, metallic, what? Roughness, occlusion, normal, good. And now we apply our function. So apply effects, mf global weather, apply effects. I just put it here and put it into the output. That's it. A single function that darkens the base color, makes surface more shiny, and flattens the normal a little. So look at how simple that is. I just put it at the end and save. And let's see. Let's see. We have the same material, nothing changed, but now I open this global weather, this material parameter collection that I read in the function. And rain intensity, I increase that. And nothing? What the hell? Oh, I didn't change the parent. Okay, again. Opening this, rain intensity back to 0. I need to change the parent of that material. Parent is generic simple, but with weather. Here, global weather. Good. Now, material parameter collection again. Rain intensity increasing. Can you see that? Can you see what's going on? So again, back to 0. Towards 1. Yeah. So it's already darker and shiny. It can be even darker. So let's change this apply effects function. Let's make this darker. And also let me saturate that rain intensity. So clump between 0 and 1. Because I don't want it to, to go beyond 0 and 1. Okay, here we go. So again, back to 0. Now it's clamped, so negative values stay at 0. Higher than 1 stay at 1. So I have one place to control that, right? Okay. So for other materials, let's go here. MI Fortress wall paint. It's also generic simple, so it's also changed to generic simple from global weather. And save that. This silvery thing. The silvery thing is special because it's silver, it's metallic. So we'll have problems because metals will also darken. You will see that in a second. Saving. Okay. So you will see the problem. Now I'm taking this global weather and look at the roof. It gets artificially dark while it's a metal. So, you know, the shininess changes, that's good. But it's also unnecessarily darker than it should be. So basically rain shouldn't change the color of the metal. So what do we do? Let's go back to the material function. Let's apply this rain again, 1. Okay. And in here, what I'm going to do is I'm going to detect whether something is a metal or not. So let's take metallic, get material attributes, metallic. And let's do something to rain intensity based on that. So let me get that back. Add this metallic thing. And now remap value range of this metallic. So values from 0 to 0.3 of metal. So like, you know, really metallic, like decide, sorry, from 0.07 to 0.75, let's say, for a little smooth transition, should be remapped to be from 0 to 1. So this means that everything that's until 70% metal, I treat as non-metal. Everything higher as fully metal. Oh, maybe 0.8. And saturate that result. And this is a mask of actual metals. Not anything in between. Okay. And on such a mask, I want rain intensity to be 0. So rain intensity goes to B, no, to A, but in that places, it should be 0. Let's move it back. Yeah, B0, rain intensity here. Ah, still bad. You know what? Let's duplicate that. And let's disable that metallic from here and add another one here. Okay. Like this. Metallic. Mask of actual metals. And this thing will be blending between the original rain intensity and rain intensity on metals. So rain intensity on metals. Like that. Uh-oh. Yeah. Oh, Adder, you are totally right. That I should change it only for base color. Right. Effect. Opacity of effect on albedo. That's albedo tint on metals. Or rather, how much does the effect apply on metals? Yeah. So we'll use a separate alpha here. And thanks Adel for pointing out. And actual original rain intensity for other things. Apply on albedo, on base color, on metals. Yeah. And now it should be better. Let's take a look. Compiling. So take a look. When rain intensity is 0, and we move towards 1, things change, but the metal changes only its roughness. So yeah, roughness changes, but the color doesn't, because metals shouldn't be dark in PBR. So that's it. We have a scene like that. Rain intensity 0, rain intensity 1. Dark, shiny. Okay, this doesn't have this applied, the ceiling. So let's use weather shader again. Good. Is it on everything now? I think so. But look what happened. The rain is correct here, right? 0, 1. However, it also applies to the door. Why it shouldn't, right? They are a vertical surface. So what to do? What to do? Let's open this function again. Let's read the global normal and modify rain intensity. So global, no, normal, what? Normal? Huh? Normal WS? Yeah. Pixel normal WS. And let's use it. So rain intensity will differ by the dot product of pixel normal and constant up. Z up. And this dot product will remap that, for example, between half and 0.7 remapped from 0 to 1. And by the way, if you're wondering about this dot product and what the hell is it, then on techardday.com in products, I have Techart Math Essentials. So this series is 4 videos that explain you the dot product and a lot of effects based on it. LERP, how it actually works and what can you do more than just blending. Sine, how to use that. And crazy effects with sine, like even writing your own rotation node. So highly recommend it if you can afford that and if you're interested. So the dot product here is basically a mask based on angle. So remapping, now saturating, and let's name it. Name it to be mask of top facing surfaces. So to show you how does it look, I will do a weird thing right now. I will lerp between the default base color and red based on that dot product. Okay, so top facing surfaces according to that mask will be red. Should be red. Huh. Okay. Ah, sorry. Okay, can you see it? So basically everything top facing is red. Stuff in between is a transition. Yeah, like here. So the door is white because, you know, it's not top facing, but everything top facing becomes red. And here's a little transition. So I will use that to mask the rain. Not to make it red. Let's delete this. But basically we have that intensity here somewhere. Yeah, how much does effect apply on base color on metals? So also I will multiply rain intensity by that value, by that mask. Like this. Let's save. Oh, error. Why? Invalid node is for normal input. Okay. Let's do it vertex normal. Okay. And normalize it probably. Because it's interpolated. Should be much better now. So we have this mask of top facing surfaces. Okay, so as you can see, the door is not that shiny now, it's normal, standard. Only the top facing surfaces get modified. So again, let me go to that global weather, control the rain. So yeah. The only thing that changes are top facing surfaces right now. The door is unchanged. So we have our global wetness, right? So now it's all very, very uniform. Shininess all over. So what can we do? What can we do? Here, let's read. Again, vertex normal no, word position, absolute word position, excluding material offsets. And in this word position, we can use it to project a texture. So word aligned texture, word position goes here, texture object, some noise basically. Some noise, heat noise, no. Natural mid. Okay, how does it look like? That's bad. Huh. Maybe this one. Oh, that was good. Blue channel. Let's take it. Workspace normal, whatever. Ah, workspace normal should be vertex normal again. Projection contrast very high. 16. Texture size, that's interesting. Let's do something like 8 meters for now. And XYZ texture comes here. We do component mask, take only blue, and we multiply our rain intensity again. So this will be called variance texture. Texture. Let's display that again. So as a base color, I will just lerp between, let's say, white and blue. Gray and blue. Using that texture. So what I'm doing is in the function, I'm projecting a texture globally using a triplanar projection. Spicy, welcome to the chat. Spicy says, I've been watching you for a while and I need to ask an important question. Did you know Rafał Piesiak? Yeah, I did. For a brief while. Take a look. So this is a texture. This texture, blue channel. And it's projected inward space. So now I'm gonna use that to break down this rain intensity. So let's lerp it between, let's say, lowest rain intensity will be like 0.5, and use that to multiply the rain intensity. And here, let's put the normal standard base color again. Debug out. Okay, so what I'm doing is first taking rain intensity, multiplying it by the mask of top facing surfaces, and then by multiplying it again by variance texture, by this texture. Let's take a look. And Spicy, why are you asking? Out of curiosity. And thanks for being a frequent watcher, by the way. Frequent viewer. Okay, look. So our rain intensity is broken down. It's a little different. It's no longer uniform. So let's do again this collection towards 0 and towards 1. Ah, I should clump it at 1. So rain intensity saturate. Yeah. Okay. So again, no rain, some rain, full rain. The texture is too frequent for my taste. So let's do the texture size, not 800 centimeters, but more like 2400. Okay. Better, I would say. Or too repetitive still. Let's do 5000. Okay. Way better. So now your, homework would be to add some good rain particles to work with that. And by knowing how to read the global, like vertex normal and everything else, you can actually start modifying the normal by adding some animated ripples from an atlas. But this is something big, and this is something I would like you to do in your spare time as an extension. And by the way, I have a patreon.com/TechArtA, and in the top tier, I'm giving also the project files. So Patreon is basically a place where I put all of the recordings later, like material tricks, making pretty shaders last time. And then at the top tier, you can also get the project files. So you can take this and expand on it. Take a look. We have the variance. The shininess is broken down a little. Oh, Spicy says that he's a moderator on the channel of Rafał. So Rafał, Piesiak, we actually know each other from 2014 or 2015 from one of the companies. Basically 3 companies ago. Spicy says he's sorry, it wasn't for not being active on the chat. No problem at all. No problem at all. And glad to have you here. Okay, so now having this, I think you have a base to do anything you want. Now the one problem you will face, oh, and that's a good question, Manuel. That's a good question. So let me just finish. The one problem you will face is that this rain will be active also in interiors. And there's no easy way to do it. So see, 0, like dry, and then you increase the rain, and everything's glossy, despite we being in interior. But it's not an easy thing. What you may want to do is to render the scene from the top, okay, from the top, and mask out every height that's lower than the captured height. So that's how you can approach that. But first, making this dynamic. Oh, Adder, you are the lucky guy. Just 2 workplaces ago. Okay, so Emanuele asked how to make this rain dynamic in game. So let's do it. Let's do it. Let's do it like that. Maybe a button? Button would be cool or no? Maybe no. How to actually do it? Okay, I can add that on begin play, it will just start. So I have this blueprint of lighting. Let me go to it. Brush to asset. Ray intensity 0 by default. Okay. Let's duplicate that. Duplicate. Oh, come on. And do BP lighting. BP. Global weather. Lighting. Okay. Can I replace the base class without losing settings? Let's try. Do you know, chat, how to do it? That I just replace this with that. Replace. Okay, let's move it first to global weather. Replace the selection with this without losing settings. Okay, seems to work. Let's rename it. Okay. Dragomir says that capturing from height would not solve the problem of open floor spaces. You would have to pre-process that with raycasting from a given module. Oh, so like softening it or something, right? Okay, we have this. So let's make it so that by default, the fog will be very weak. Wait, let me delete that. Oh, what have I done? No. Bring it on. Okay. Looks good enough. And now look. Now I will do that. Rain intensity, right? So let's do a variable. Let's call it rain intensity. Good. And on this rain intensity, let's delete that. So on begin play, even begin play, we will start a new event. So custom event. It will be called, how to call it? Or no, do we need it? Maybe not. Actually we do. I think we do. Update wave. Okay. And on begin play, we create a timer. So there will be a timer handle variable. Weather timer of type timer handle. And we set this to timer, set timer by event. Set timer by event means that this timer will call that event. So on begin play, we start this timer. It will happen every 1/30th of the frame, not too often. It's not looping. Yeah. So this will update our stuff. And also there should be another timer. So this weather update timer. And another will be weather blend timer. Weather blend timer. So let's set that blend timer. Again, set timer by event. Or do I need this? Not exactly. Just set timer. By nothing. Ah, actually by event, maybe. Okay, by event, whatever. Like this. Or do I need that really? I don't think so. Okay, so I just do weather blend duration float like this. So get. This is how long it will take for the weather to blend. So this weather will take. Actually, you know what? Let's do a sequence. First, set this weather blend duration. Then set this other timer. So the thing is that I want the blend to take, let's say, 3 seconds. Okay, 3 seconds. What's the error? Empty event. Oh god. Can I just set a timer without nothing? Just timer? Maybe like this. Seems to work. Okay. So this timer just will tell us when the 3 seconds have passed. And the other will update this weather all the time. Until this is hit. So update weather. What it will do? It will lerp. There's no lerp. Yeah. Lerp value. It will lerp rain intensity between current rain intensity and 1, with the alpha being the time that has passed since the start. So alpha will be map range clamped from 0 to duration. From 0 to duration will be remapped from 0 to 1. And the rain intensity will be updated. So wait a second, that's wrong. We don't need that. Lerp. Just that. And we need the time that has passed, so weather blend timer get timer elapsed. Just like this. So, you know, the time that has passed in the start of the timer will be remapped from 0 to 1 until the duration is reached. And we just set this value. So this event just sets float, set scalar parameter value from the collection global weather. This is the collection that has our rain intensity, and set the param value. Okay. For those of you who weren't there earlier, this is a good, you just do materials, material parameter collection. You add a scalar or vector parameter, and you can easily get it in materials and in blueprints. So back here, I just have this global weather, rain intensity that I added, and I set this value. Okay, so having this, I need nothing more because this is just my event. There is a timer. I need one thing. When the timer is reached, this should be broken as well. Actually, how to do it? How to do it? When this is finished. Okay, so let's do something like if this weather update thing, where is it? Weather blend is active, is timer active? If it's not active, then just, if it's not active anymore, delete this timer. Actually, I can do an event. I can do an event. So by event, set timer by event. So the event will be custom event, finish weather blend. And what it will do is it will take this weather update timer. If it's valid, then just break it, so stop it. Utilities time clear and invalidate time by hand. So branch, or just even without it, just invalidate that timer. So you know, this is supposed to take 3 seconds. When it finishes, it will stop the weather update. Okay, and the weather update again takes the remaining time in this weather blend and remaps it from 0 to max duration to 0 to 1. So the rain intensity goes from 0 to 1 in 3 seconds. That's it. Sets the global param in our weather. So let's again do it manually just to show you. Rain intensity from 0 to 1. Okay, everything is shiny. Things are wet. Now back to 0. They are dry. So let's start, and the blueprint should do it by itself. Yeah, as you can see, gradually over time, it became wet again. You can see the roughness decreasing, materials getting darker. We can do base color also, base color. Yeah, so see, I do play, things become shiny. So I hope, Emanuele, that answers your question, how to control that effect in-game, how to make it connected to the rain. You also can apply this now to particles, to everything. Just control all with this rain intensity stuff. And either pass it to effects or just control the material of effects directly. Stuff like this. Okay, so we have that. Now we should also control the fog. So BP. So not only does it set the scalar param, but also the fog. Wait, current height of the fog is 0. So let's make it at 2200. So that set relative location, okay, of exponential height fog from lerp vector from 0, 0, 0 to 0, 2200. And alpha will be also this mapped value. Intensify fog. Okay. So the fog color could be different. So also fog, that color. This is fog in scattering color, right? This yellow. Yeah. So let's also lerp it using HSV from Maybe even not, or maybe this. What was the color again? Or maybe let's even change it to green or something. Yeah. Change it to green. Maybe like that. Okay. Okay. So this is the initial color. Let's copy that color. Paste it here. From this color to gray, basically just cold gray. And dark. Okay. So it will also lerp this fog color based on the same value, this remapped. Until is out for today. Bye. See ya. Let's also finish soon. Okay, so let's play that. And look. The fog is intensifying. The surface becomes wet. From this to that. Okay. Let's make the blending maybe RGB. So lerp RGB. Lerp color. Copy. Copy. Okay. Good. So again, play. Becomes gray, intense, and shiny. So this is it. So now the last remaining problem is that it's dry in the inside, but when we play, it becomes wet over time. Wet over time. Oh, hello there. Szarżujący jednorożec is raiding with 8 people. Nice. Welcome. Okay. And how was your stream? And what are you doing? What were you up to? Welcome to the old bro. Okay. So is it you, Rafał? Or? It's Rafał. You just missed Mikołaj. He left like 5 minutes ago. What were you streaming today? There's a question, why English stream when you are from Poland? Why not? Why the hell not? CSGO, okay, not Unreal, not Techart. So yeah, what we are doing today is we're trying to make things wet over time. So there's a map, this is different material, there's different materials, a single material function that we created, like this. It takes the existing material attributes, darkens the base color, makes surface more shiny by changing the roughness, flattens the normal a little, and puts it back into the result. So all of this is based on a rain intensity global parameter. You do it like collection parameter. Mask of top facing surfaces using the dot product, and also variance texture here. So the global texture that breaks this a little. And about this dot product stuff, so this is quite a simple math, but still good to know. So yeah, I already showed that I have a Patreon here, but also on the techardate.com, you can find the math essentials. techardate.com and products. So here I explain the dot product, lerp, quite advanced things using lerp, sine, and creating your own rotation, and noise using sine. So this is quite a short course. Math basics like this, very useful, I think. So yeah, the last remaining thing is that we don't have any masking in the interior. When I mean the interior, everything gets shiny over time, like everything is like wet. So what I mentioned, and I don't know if I want to do it today, but because maybe it will take too much time. But one solution could be to place where is it? Where is it? I mean the scene capture. All classes, scene capture 2D, right? You place it somewhere. Let's say 0, 0, 2200. Okay. Where is it? The scene capture. Oh, here. Do stuff like this. You create a render target. Materials, render target. Where is it? Textures? Textures. Render target, RT, global weather, height. Or like scene height. Well, yeah, that's it. Just rename it. Scene height. Okay. Put some resolutions to it, like 512. Format, definitely 16 bits at least. But float maybe even better. 32. Float. And then having such thing. Perspective, no. Orthographic. So let's take a look. It captures nothing, it's dark. Because it's not connected to that capture. So in the capture, select render target here. Currently it writes color. That's the default mode. There's the ortho width. Like that. Yeah, so as you can see, it renders this level, the scene. It renders the scene, but it renders the color. If I change the render target mode to colorful, without alpha, you can see it, right? Basically our scene. So let's change it from color to height. And I don't know if it's possible by default. Capture source, yeah. Scene depth, like this. Scene depth in R. 32-bit. Float, of course it's clipped, right? Because it's in centimeters. Orthographic. I don't know if it's valid then in orthographic, but we'll see. Let's move it to 0, 0. Ah, sorry, 0, but 2200 or something. Good. And now we'll need to read that. So let's read that. Let's open this material function. And we'll display that as a, I don't know, base color. So let's take it. And let's lerp between gray and some kind of extreme violet. Okay. Based on this height, but remapped. So remap value range, separate of course. Red from 0, or no, from height start to height end, right between 0 and 1, and displayed as a base color. So here we have our texture, which is the scene height taken from the scene capture. Let's try that. Okay, compiling. Some color is already there. Yeah, the wonderful wait for shaders. Nagomi asks if I could push Unreal to do a better shader node with auto completion. You know, this company, they work in their own engine, okay? They're doing Fortnite, they're doing Matrix demos, they do all kind of stuff. So if they can't help themselves with a better custom node, like code-based node, then what are my chances really? What are they? Epic works with this custom node as they made it like all the time. And they probably think it's good enough. Legomil says my chances are higher than 0. That's true. Like 0.00001. But maybe I could make a live sync with Visual Code Studio. Visual Studio Code. Oh, compile finally. Like how much time can it take? Does it do anything at all? Apparently it does. I can't believe it. It's too slow. Can I just close Unreal? Maybe I crashed it, yeah. I'm closing it. My function was too complex. It had remap from 0 to param. Unity for the win. Not exactly. Not exactly. Okay, here it is, look. Preparing again. This is what crashed it. Remap. Crazy stuff. Oh, it unlocked. Okay. Perfect. Take a look. Beautiful color. Now, what does it mean? It means that there's a scene capture actor on top. It reads the height of the scene. And now I do a remap between 0 and 1. Let's do between 0 and 1000. Oh yeah! Take a look. What is it? Appeared automatically when I changed 0 to 1000. What will happen if I do 1100? 1200? Whoa! 1500. This is unexpected. Getting better and better. Okay, let's do something bigger. This is already becoming weird. So like 500 to something more. Hey, that's super weird. Because of the UVs. Okay, so that's one remaining thing. We need to recreate the projection of that camera. So that camera is placed in 0, 0. That's good. And it has an ortho width of 31,000. 3100 doesn't make sense. Let's do 3200, like whatever. Just that the scene is fitting inside. So I need to remap between minus half of this to half of this. So in my global param, I'm going to do scene capture width 3200, the same thing like here and here. Okay, 3200, 3200. You have to synchronize it in the actual game, you know. It doesn't matter now. I take it here, so collection parameter, scene capture width. And I need to create these UVs. So UVs will be world position, excluding offsets or whatever, or including component mask, R and G, and now this world position, no, actually R and G separately because Unreal is stupid and its remap node is just one channel. So again, remap value range from that's multiplied by half and by minus half. And I'm going to remap the word position so that I get UVs of that orthogonal capture. So remapping from minus half, scene capture with half of it, negative, positive, 0, 1. Okay. The same for red. The same for green. Append. And let's call it generate. Calculate UVs for the scene capture render target. But recreate UVs of the scene capture render target. Okay. Putting this as UVs, and the mode will be sampler source clamp. Okay. Let's try now. Should be mapped much better. Okay. Ah, preparing shaders. Okay. Cool. I don't know. Ortho with 3200, yes. But what is displayed here? What is it? What is all of that? Let me display these UVs as a color. Let's bring them as base color. Oh, error. Cannot cast. Compiling. So here we go. So these are the UVs. Here they are, of course, out of range, but still we should see something. And what is actually visible in that scene capture? Let's open the render target and let's do scene color as the capture. Scene color. Okay, this should be visible. So let's make ortho with like 6400. Right. Let's make it 6400 in the material itself. Okay. So what's wrong? If the UVs are correct, I should be getting like add these UVs, get that texture. That's it. Okay, I actually know what may be happening. So the scene depth, maybe in different units. Let's go back to this capture thing. Can I get, instead of scene depth, something word position or something? Capture source. Final color. Scene depth in R. It should be fine. But I don't know what the depth means in orthographic. Okay, I know what we do. We just display that as a frac instead of saturate. To just know what's going on. Okay, apply. They're gonna ask if I need a scene capture because I could get it from a node. But yeah, I need a scene capture because I need occlusion. So that only one pixel from the top is written. I could read scene depth in the scene height in the node itself, but yeah. Okay, here it is. Let's change the values so that height start will be 0, height end 1. Wow. Okay. Nice, I would say. Let's add some actual object like geometry. Using the same material. So like fortress, ground. Yeah. Okay. Okay. And now let's increase that top height 10,000, 1,000, 2,000. Okay, we see some kind of transition. Let's start at 500, 1,000, 1,500. Yeah, already better, yes. But still very blocky. Whoa, look at this. I exceeded some value. Okay. So this is definitely working. I think it is. So let's start at 0 and remap it until, yeah, until that effect. Okay, so like 2600 maybe. And the minimum, okay, so let's replace it with saturate again. And just, you know, trying to find the minimum and maximum. So let's do this height start higher again. Huh. That is actually very weird. But maybe the scene depth is not the distance. So this should be remapped to something. I'm not sure. This is no, it's a very weird effect. Look at this. What even is it? Ah, let's move this capture a little. Yeah. So yeah, it's definitely distance to that camera. That's the problem. So start. It should be like start 0. And end should be this camera. But wait a second. It's inverted. Right? Yeah. That's why it's so weird. Okay. So this has to be rotated. Now it's good. Okay, sorry. 90 degrees. So take a look. Now it fits. White on the top. Darker. Yeah, makes sense. So now we have probably the distance, the height. But I wonder if this is in centimeters. This is correct. Because wait, we got white at A. So white is at 0, meaning white is at actual 0 from the camera. So to get the actual height, we would have to remap from camera height 2200 to 0. Yeah. Let's try this. So instead of this lerp, let's just compare if the pixel is, how does it compare to that height? So let's get it. Let's get word position. Let's mask by getting component mask. Oh, Mandeliane Rocto. First time in the stream. Thanks for speaking in the chat. You didn't get into nodes at all. So yeah, one of my maybe not nodes by themselves, but shaders. One of my favorite parts of TechArt in general. So this thing we're doing today is quite advanced, as you can already see. But yeah, what we're trying to do, what we have is adding rain effects, kinda. So making the surface wet in the material, but now we're trying to mask things that are below the ceiling. So occluded things. So I have a camera on top that renders the scene to a texture. And then absolute worst position, B. So this is our actual height. This is the height that we are getting here. We don't need that remap, to be honest. We just need this. So name reroute. But wait, we're not getting height here. We're getting distance from the camera down. So it increases while it should decrease. So I should just invert it. So Rafa, you are saying that you will set up an empty helper objects and remap from the object position to camera position. I don't know if it's possible in Unreal easily, but in material I can actually, yeah, I can do a remap from height start to height end and just invert that. So to height end, height start, invert. From scene capture. Origin to ground. Okay. Maybe it will work. I'm not sure. Let's delete that. Ah, this is useful actually. Let's skip it. Okay, so our worst position. Let's compare that with if. So if word position is bigger than the height, use pink, magenta. If it's lower, use white. Let's see. So yeah, we're taking the scene capture content, inverting it. So from 2200 to 0, inverting from 0 to 2200. And comparing with the actual height of the object of the pixel. So here it's all pink, but inside, it also is. Okay, something's wrong. Something is definitely wrong. So wait, we have this height start. But it changes nothing. Here I have the scene height. Can I make something like max exposure to preview that? Probably not. No. Huh. So when it's bigger, when the height is bigger than what was read, do this. When it's lower, do that. So at least in some places it should differ, right? Because here I'm inverting. Huh. What am I doing wrong actually? This value is the distance from camera to the ground. So it should reach 2200 at 0. So I'm changing it the other way around. So what was from 2200 max to 0? So ground level. Height, ground. Height, sync of character. Remapping it so it's from 0 to 2200. Saturate. Oh my. B. Okay. Now it should make more sense. Huh. Very good. Yeah, so now it works. Of course it's chaotic because these values are so close. They're so close to each other, so we'll need a little bias. The same problem as with shadows. So to our height, we should add height comparison bias, just to, prevent it from being identical. So it can be given, 10 centimeters, and just apply. Rafał says that's interesting. Cool. Cool to hear that. So this bias, you would use exactly the same when doing shadow maps by hand, manually. So when implementing shadows, you also compare the depth from the light source to the actual position of the pixel. So look, just by adding this bias, we remove the problem. 0, 1 centimeter, 2 centimeters, 10 centimeters. Of course, the let's say shadow is moving when doing this, but it doesn't matter that much compared to how much does it help us. Okay, so we already know that if the height of that pixel matches the height from the scene capture from the top, we can apply rain, while below we shouldn't, because it's masked out either by the roofs or by the ceiling. So inside, yeah, it's going crazy. Let's increase that bias. Or the other way around, -50. So yeah, in the interior, everything clean. But now we have the opposite problem. So as you can see, this biasing is not ideal. It's not ideal. Okay, so just 5 centimeters is enough. More than enough to fix the issue. Okay, so we have masking. So now let's apply that mask. So all this, let's replace that. And let's put ping is 1, this is 0. So 1, 0. Okay. Recurrent UVs of the scene target. This is read the scene, read the depth from scene capture, then invert it to get actual work height in meters. Okay, and this is compare pixel height to top down, to capture top down height. To make an occlusion mask of rain. The first ceiling will block rain below. The first rendered ceiling will block the rain below. Okay, here it is. Now the last thing, let's move all that. Let's move all that here. And the last thing would be to multiply by all this. So I need to move that again here. Mask rain in interior. Or remove rain in interiors. Okay. And now we also multiply this again by that interior mask here. And the base color should be the actual base color. Okay, so this is our material. First, we mask out metals from changing the color. Mask out top facing, so we apply the rain only on top facing surfaces. And then there's a little variance texture to break it down. And removing rain in interiors. And what does the rain do? It tints the color to make it a little darker. It makes the surface more shiny. And it flattens the normal a little. And all of this is a material function. So that in our materials, like this one, we just put it here. Global weather apply effects. It takes material attributes, applies this darkening, this shininess, and so on, and puts material attributes at the output. So this way we have a single self-contained material function and a single material parameter collection that has rain intensity, and it controls all that. So this is without rain. Rain strength is, rain intensity is 0. Let's wait for shaders. So now this is rain 1. Shiny, darker. So again, 0, 1. And as you can see, it doesn't apply in interiors. 0, 1. Thanks to the scene capture that we have that renders the top height of everything, and every pixel compares its own height with this rendered height. So take a look. Under this shape, there is no rain. The rain intensity 0, 1. Rotate that. Just like this. Of course, the edge is sharp, but you can break it down a little. So again, rain 0, rain 1. And now let's simulate to have it in real time. Again, 0 rain. Over time, it intensifies. So the top surface is shiny, and below there is no rain. Everything became wet except for under the shape. The same here. So let me play that again. Let's open the door. And inside, as you can see, shiny. And inside it's dry. Okay. Dry. Shiny. Lego Meat tries to find edge cases. Okay, so that's it for today. So once again, let me recommend you getting on patreon.com/techardate. If you get the middle level or the higher level, you get the recording of this, and with the upper tier you get the project files. So see you next time, and let me know if you have any questions on Discord. Cheers. Mofino said really cool effect. Thank you.